Okay, so g at x is the inverse function of f, but how do you get inverse function? You have to switch the x and y symbolically, right? And you gotta isolate the y, right? So let's switch. Let's do the switch. 2y plus 1 minus, like that, right? But it's very hard to isolate. Okay, but we don't need to. We can just do this implicitly. Yes? Yes. So differentiate both sides implicitly in terms of x. We get 1, 2y plus 1 ln of 2 times by y prime, where y prime, okay, y prime is a derivative of g, minus 2 ln of 2 chained by the derivative of minus y, which is plus 1. Okay, y prime. Okay, so now you just plug in 1 into. Okay, look, do you see how we need the y values here? We don't have the y values. They just give you g prime at 1, right? So where do you find the y value? You gotta plug in here 1, and solve for y. Okay, so you get 1 is equal to 2y plus 1 minus 2 to the power minus y. And I want the difference between these two to be 1, so I can see that if I do the guess and check, it's going to be 0. But we could, factor out 2 to the power minus y, and you get 2 to the power of, what is that? A y, 2y plus 1 minus 1. Okay, and then you got to do a cross multiplication. And it'll become a quadratic, right? So this is 2 times 2 to the power of 2y minus 2 to the power of y minus 1. Right, so you get 2, 1. You just want this, so you get 2 times 2 to the power of y plus 1, and multiply by 2 to the power of y minus 1. So we get 2 to the power of y is equal to -12 or 1. That's impossible. So that's the whole process. But we could also just do a guess and check there. It's not that unreasonable for you to do a guess and check here. So anyway, 0. And then what is that? It's y prime. You can factor y prime, so you get 1 over 2 ln of 2 plus ln of 2. 3 ln of 2. 3 ln of 2, b. D, sorry. D, because I had a 2 at the top.